Hi, my name is Joseph Love, and for my senior thesis I have developed a telemetry system for the Union College Aero Design team. The Union College Aero team aims to compete in the regular class competition this year. The goal of the regular class competition is to carry as much weight as possible while still maintaining lift and landing properly. Here you can see a photo of the first prototype that we have developed. This gives you an idea of the scale of the plane, and this gives you an idea of where the telemetry system goes. This is the brain of the plane. My senior thesis goal is to not only create a telemetry system for this year's team, which will help improve future models, collect data while the plane is in flight, but also to develop a telemetry system for the advanced class competition. In the advanced class competition, the goal is not to carry as much weight as possible, but it is instead to drop a 3-pound humanitarian aid package onto a target from at least 100 feet. Here's a mock-up of the plane. This is obviously not to scale, but we can see 3 sensors on board. We have an airspeed sensor, an altimeter, and a rangefinder, located on the bottom of the fuselage. The rangefinder allows us to know whether or not we're sitting on the runway. This allows us to later sync up our data and tell when we took off and what our airspeed was at that moment. Calculating airspeed at the time of liftoff is important for knowing how much weight the plane can carry. The red LED indicates whether or not it is powered on. This allows us to look at a distance and see whether or not the system is working. There is a yellow LED that will light up when the system is working, if we are reading, clearing memory, or if we're acquiring data. This allows us to see from a distance and make sure that the system is working. When the system is plugged into a computer, the user gets 3 options. They can either run the data acquisition system, read the memory from the previous flight, or clear the memory for the next flight. If you want to run the data acquisition system, you can also press this button here. This begins zeroing out the altitude so that we know where we're starting. This allows us to tell our change in altitude rather than our absolute altitude. Since we're measuring altitude based on pressure, this can change due to weather. Now that the display is giving us information, we can see altitude change as we lift and lower the plane. We can also see our airspeed change if we blow into the airspeed sensor. Lastly, the time of flight sensor or small range finding sensor uses IR and the time from the reflection to measure the distance from the ground. This is on the bottom of the fuselage of the plane and should allow us to see if we're sitting on the runway. For instance, if we're on the runway, that measurement should be very small. This sensor maxes out at 255 millimeters, so if we're reading 255 millimeters, we must be in the air. This allows us to later sync up and tell what our airspeed was when we lifted off. As I said before, the GPS is not on the plane. If it was, we would be able to measure latitude and longitude, ground speed, and time from the satellites. Ground speed is important because that, along with altitude, allows us to calculate the lead time or lead distance to a target. I've run MATLAB simulations of this, and we can see a model of that here. After a flight, processing the information is relatively simple. I've written a MATLAB script to do most of it for us. You just save the information from the serial display to a text file. Then you import that into MATLAB and run the script. You will then plot the data and it'll look something like this. This is from a simulated flight done in the lab, as the only flight so far crashed after about a second and we were unable to gather data because of a wire snap. But this is a simulated flight. You can see the peaks in the airspeed because I was blowing into the sensor, and I can't do that continually. You'll see the altitude decrease and increase as I lifted and lowered it, and you'll see the time of flight sensor sitting on the ground and then at 255 as we're in the air. If you want more information about my project or the team's status in the competition so far, feel free to visit my website here. It has lots of photos, videos, and information about my project so far. Thanks for watching.